And today we're going to be solving quadratic equations. And the last time we saw one method, solving by factoring, in the last homework assignment. And let's see, I'm going to write out the three methods, if you can switch it over, that we're going to be seeing today. The first method is by factoring. Y'all remember factoring from the last time? Say yes. We just did an example earlier before we were recording. Okay. The second method that we're going to see today is the square root method. And the third method is the quadratic formula. And so method number one, factoring.
We've already done that. Why are you writing
that
down
was all
factoring?
we did that.
Previous assignment.
Previous assignment, good. The second method, the square root method.
I think I'll discuss it.
Okay.
I always tell my classes with the square root method, you can sort of figure it out on your own. Just by looking at an example, EX. Oh, instead of this. Suppose we had this. X squared equals 25. I think based on your knowledge of the multiplication tables, you could tell me the answer for x.
5.
Okay. If we squared 5, we'd get 25.
But there's another solution.
Yeah, what if I told you there's actually two solutions? Not just positive 5, but negative 5. So trying to show my thought process here, what I'm going to do. Why do you put it? Is write it like that. I'm dropping the square on the left and taking the positive and negative square root of the number on the right. So our answer here would be plus minus 5. Okay. Now, with the square root method, the equations have to be written in a particular form. Okay? It can't be written in like this problem right here. It's a quadratic equation that we solved by factoring one day. But you wouldn't want to use the square root method there because you don't have it in the form x squared equals a number.
There's something, I always say something squared equals a number.
Okay.
That may be more than just a variable being squared, but you have to have it in the form. Something squared equals a number.
Okay. And if it's in that form, then going from here to here, I'm dropping the square on the left and then take the positive and negative square root of the number on the right. So on the left, I drop the square. Theoretically, what I'm doing is taking the square root. And over here, on the right, I take the positive and negative square root of the number. But it has to be in that form. X squared equals a number, or something squared equals a number. And you'll see why we're saying something in a moment. Let's look at problem number 4. There, 4. Oh, what is that? 4x squared equals 44. So this is problem number 4 in the homework. 4x squared equals 44.
Oh, let me ask you something before I switch to the paper. What's being squared here? Not the 4, only the x. The
So
only thing that...
4 to get x squared equals 11.
Okay. You have to have it in the form something, the thing that's being squared by itself. The 4 isn't being squared. If we wanted the 4 to be squared, we'd have to have parentheses around the 4 and the x. The only thing being squared is the x, so we got to get rid of that 4.
And we'll do that by dividing both sides by 4. So we have x squared equals 11. Now, it's in the same form that that previous example was. The x squared equals 25. So we can drop the square on the left, take the positive and negative square root of the number on the right. Don't let the fact that you're not going to be able to simplify square root of 11 scare you too much.
That's actually real nice. Just 11's a prime number. There are no perfect square factors for 11. So what do you do with the square root of 11?
Just
leave it as it is. Why don't you circle that answer?
Okay.
And that says that we're through with the problem. When you're circling that answer, it's pop psychology. You're saying you're done with this problem, you're ready to go on. Well, we have to type in the answer, so let me come over here.
It kind of closes the answer in, so it can't escape.
Yes. So we click here. Notice what's about to happen. Okay? You click there, and look, we got our toolbar, and look for plus or minus. There it is.
It was around 2015, 2016 when they introduced the plus minus key. And I knew at that point I am old because I was just so happy. For years and years and years, there was no plus minus key. You would have had to type square root 11, comma, negative square root 11. And you think, well, that's no big deal. When we get to the quadratic formula, you'll see that the plus minus key is a lot better than typing it as two separate answers.
Now remember, we were typing square roots with complex numbers, so we know to use the little square root but hot button down here on the toolbar. We have an 11 underneath it, and check my answer. As long as the equation is in the form something squared equals a number.
Usually x squared equals a number, but you'll see what, when we say something. Let's see, what's this one? Number 5. 3x squared plus 6 equals 0.
What do we do for this? Because there is no simple.
Yeah, but can we get it in the, what's being squared? When you look at this equation, what's being squared?
Not the
Not
3, just the x.
So we minus a 6 on both sides, then divided by 3 to get x squared equals negative 2.
Did y'all hear that? Oh. You subtract the 6 from both sides, so you have 3x squared equals negative 6, and then divide both sides by 3. So at this point, instead of saying just something squared, if there's no parentheses in the problem, your goal is going to be written as x squared, 10.
Whatever the variable. Oh no.
I'm sorry, y'all. Look at this.
Away.
Okay, I subtracted the 6 and then divided both sides by 3. At this point, your goal is x squared equals a number. You'll know when it's going to be something other than x squared equals a number. Well, are we now ready to drop the square on the left and take the positive and negative square root of the number on the right?
Well, would it be a positive negative square root, or would it just be a negative because of the fact that it's a negative 2?
It's still a positive negative square root of negative 2.
Do you ever want to leave a negative number under a square root?
If you type this answer in my math lab on Pearson, it's going to say wrong. Why? Never leave a negative under a square root symbol. You can't do anything to simplify the 2, but you can write it like this.
Let's see if they remember. What did we do in the second homework assignment when we had a...
If you had a purple negative under a square root, I'd write a purple what? I.
Imaginary number.
So anytime this semester If you wind up with a negative number under the square root, don't leave that negative. Put an I there. Can y'all see this? Plus minus I square root of 12. Square root of 2.
Any questions?
The reason we have the I is because of that negative under the square root.
Question.
Yeah, so what's the purpose of the positive negative again?
For the same reason, going
The
back to
same
our very
reason?
first example, for 20, if you think just 25, what number can you square to get 25? Not just positive 5, but also negative 5. There's two numbers. If you think, don't think of the messy square root of 11 or square root of negative 2. Think just of x squared equals 49. What two numbers can you square to get 49? 7 and negative 7. Okay? So anytime you're squaring a number, you can always square a positive and negative and you'll get the same thing. Like x squared equals 36. You could square 6, positive 6. You could also square negative 6.
With the square root method, you will have the positive and negative option. I remember back with the test generator, and my math lab would give those multiple choice questions. They would have they'd ignore the plus minus, and we'd stand up here telling people, oh, don't forget the plus minus. Sure enough, half the class would choose the one that didn't have.
I don't think it was half.
Not half. Not half, but still. Let's punch it in. The plus minus, and then the square root.
Oh, wait. No, you got to put the I.
You're right. I forgot about that. I was about to put an 11. Where did I get an 11?
That was
I
another
put my
point.
I there. And what is this, a 2?
2.
Is that what I wanted to enter?
Mm-hmm. Now,
Any questions? Any more questions there? You have to be able to get the equation in the form something squared equals a number. And if you can't get it into that form, then you can't use the square root method.
okay, the way he's saying something squared equals a number. You can now, let me see this, before they write that down. Here's the two things you want. Either x squared equals a number, or if there's parentheses in the problem, if you can write it parentheses squared equals a number, you can do that square root method.
Mm-hmm.
So there's two main ways that you can use the square root method. If you can write the equation in the form x squared equals number, or if you can write it in the form parentheses squared equals number. And I suspect on number 6, it's going to be parentheses squared equals a number.
I know it is because I'm looking at it.
Oh, yeah, okay. Ooh, I wonder if we can make that a little bit bigger. If we do this, is it going to get too big to... Oh,
Yes.
oh, yeah. That.
There.
Oh, okay. So problem number 6, 3x minus 1 squared equals 33. It says solve the equation by the square root property. Okay, square root property. We say square root method. Is it in the form something squared equals a number? Yeah, it's in the form parentheses squared equals a number. So let's go ahead and do exactly. Oh, I like this type of notebook better. What I said here. Drop the square on the left. Take the positive and negative square root of the number on the right. So I'm dropping the square. So I just have 3x minus 1 on the left. And on the right, plus minus square root of 33. Hey, this is a multiple choice one, isn't it? You sort of see what my math lab used to be like when it first was invented. Oh gosh, first came out probably over 15 years ago.
Yeah, definitely.
Oh, yeah.
Oh, I'm sorry about that.
Yeah.
Oh, goodness. Let me ask you something before we go on. This is a DMC alert. We just got a DMC alert.
Is everyone getting one? Oh.
Belmar College has received information regarding a shooting near the Burger King on Old Brown Hill Road.
That previous problem had an I in it. What do y'all think? Is there going to be an I in this answer? No, because the number under the square root is not negative. If the number under the square root is negative, you're going to be stuck with an I in your answer. But there isn't this isn't a negative number. What about the square root of 33? Is that a perfect square?
Really, the only thing that'll do is 11 times 3.
Are they perfect squares? Can we reduce the square root of 33? What do y'all think?
No, we can't. 4, 9, 16, 32 doesn't divide even into. Did any of y'all have a Casio calculator? There's some Casio calculators that if you punch in something like square root of 12, it doesn't give you a decimal number. It gives 2 square root of 3. And I used to have one like that to demonstrate it, but in the move, I can't find it. Maybe it got thrown away from we moved from our old office to a new one, but
No, I don't think it got thrown away. I think it got boxed up
Boxed
somewhere
up.
and stored
Okay.
away.
Well, anyway, let's finish up this problem. We're not finished because it's not in the form x equals. When we're solving an equation, you always want just x equals or whatever the variable is. And so, how would I go about getting this x by itself? What would I do? To isolate the x, perform the opposite operation beginning with addition and subtraction. So, if I'm trying to get the x by itself, don't let this plus minus worry you.
Treat it like it's just a plain plus or a plain minus.
Add 1 to both sides. I'm moving that 1 over. So we have 3x equals 1 plus or minus the square root of 33.
Oh, and by the way, put the 1 in front. Otherwise, it may look like you've got that 1 here underneath the square root. So it's standard practice. If you have something that's being added or subtracted to the square root, you put the thing without the square root first. So that 1, you move over, it changes the sign, it goes in front. 3 times x. What will we do to get rid of that 3 there? Divide by 3, I agree.
And since we couldn't simplify square root of 33, you are finished here. 1 plus or minus the square root of 33 all over 3. And this was a multiple choice one, I think, right?
Yes. Let's come over and look. Now, with multiple choice problems, I guess they give you, what, 2 chances? If there are 4 options, they give you 2 chances. What is it? Is it A?
Say no. It's got to be the one that has the plus minus in it, right?
Yeah. I'm not sure. Oh, I think they went 1. Yeah, that's definitely not it. The only sensible, the only one, option D. Check your answer. Any questions there? As long as the equation is in the form something squared equals a number, you can use the square root method.
It's either going to be in the form x squared equals a number or parentheses squared. So what about the last one of these? Not that.
Oh, it's another one with
Parentheses. Z plus 8 squared equals, I think you made it too big. Is that a negative 14?
There's going to be a little symbol in your final answer. What will that symbol be?
Well, there's going to be a few symbols.
There's
You're
going to be
thinking
an
of one
I
that
in
starts
it.
with an I.
That's right.
Okay.
Because that number there is negative. When you take the square root, you're going to pick up the imaginary unit. So,
Drop the square on your left.
Switch it
Oh.
back there.
So I'll drop the square on the left. Take the positive and negative square root of the number on the right. I'm going to go ahead and put that negative in red. I need to simplify that square root. This square root we can simplify. We can't simplify the 14, the square root of 14, but what am I going to replace this red minus sign with? An I. And I may as well rewrite the z plus 8. We need it in the form z equals, so what am I going to have to do? Minus that 8. So move the 8 over. It'll be a negative 8 plus minus I square root of 14. Negative 8 plus minus I square root of 14. Oh, and I think this is another multiple choice. Let's see. I don't know why Pearson never really updated these past the
A, B, C. I think if there's only 3 options, you only have one shot at choosing the correct answer. A, B, or C.
I'm thinking it's C, isn't it?
Negative 8 plus minus I square root of 14.
Notice it said final check. That meant that if you got it wrong, you were going to have to say similar problem and do it again.
If there's only 3 options for the multiple choice, you only get one chance at choosing the correct response. If there's 4 or more possible answers in a multiple choice environment, they give you 2 shots at choosing it. So if you're just going to guess randomly,
but why would you guess randomly? You know there
has to be an
I in it. And,
you know something? Yeah. You know there's going to be an I. See, the only one with an I. Any questions there? This sort of looks like something we could have solved by factoring. We could have moved that 23 over, making it a positive 23, but it's not factorable. How do you solve a quadratic equation when it's not factorable?
Oh, so you've moved on to number 8. Okay.
Yes, but now there's something called the quadratic formula that we can use to solve quadratic equations that when they're not factorable.
Could we have used the square root method on this one easily? Say no. There's not parentheses squared equals a number, or x squared equals a number.
There's that unsquared variable.
Theoretically, there's a way you could go about and make this look like a square root method problem. That's called completing the square. Way more hassle than it's worth.
We'll see completing the square when we look at circles in a few weeks.
But let's go ahead and write out the quadratic formula. Oh, so this is going to be a formula that you just plug into, and miraculously it'll solve any quadratic equation.
It may give imaginary solutions. It could give irrational solutions.
Those are the ones that have square roots in them.
But realize A is the number in front of x squared. B is the coefficient on the unsquared variable, and C is that constant, the thing that doesn't have a variable. The value of those 3 numbers will be plugged into this formula.
So the equation has to be written in standard form, just like if you were factoring. All right, x squared x constant equals 0. The solutions of ax squared plus bx plus c equals 0 are given by, here's my formula. I think I'll just write blue. Negative b plus minus the square root of b squared minus 4ac all over 2a. Negative b plus minus the square root of b squared minus 4ac all over 2a. If you want to memorize this formula, the way to do it is just write it down every time you use it. And I highly encourage you to write it down. when you're doing one of these problems so that you can actually be looking at the formula as you're plugging into it. Okay? Now,
remember we said to use the quadratic formula. It's just like with factoring. What number do we have to have over here on this side of the equation? Now, but we're going to add 23 because you're trying to get what number here? 0, okay.
so it's y squared minus 10y equals negative 23. So that one I think you can blow it up a little. It doesn't have all those multiple choices. I think it blows it up.
Okay.
There. Okay. Now, we need to move the negative 20.
Let me switch over there.
In order to get it in the standard form, I'm moving that 23 over, so we have y squared minus 10y, and then a plus 23 equals 0.
I like to identify A, B, and C. I write out A equals, B equals, and C equals.
And I like to do the same thing.
Oh, okay.
So I'm going to write out, every time I use the quadratic formula, I write it out. A equals, now realize A is a number. A common mistake that I'll see students do is they'll say A equals y squared. No. A, B, C are numbers. A should be what number? If there's not a number in front of a variable, what do we assume is there? A 1. So A is 1. B is negative 10.
Take the sign, that minus becomes the sign on 10. So negative 10.
And then C is
23.
positive 23. I'll write down the formula, even though it's right here staring us in the face. I like to just write it down every time. And Tim, I'm not sure, I like to not show too many steps. It's like working with logarithms. If you show too many steps, it gets hard. I like to do the stuff,
I do some of the stuff in my head also.
okay. Like, I'm going to now start plugging in. Be careful.
On scratch paper.
Yeah.
I go off to the margin and do calculations on it.
B is negative 10. So if I plug a red negative 10 in place of this blue B, I have negative 10.
It would turn into positive 10.
Positive 10. This minus B really just means change the sign on B. So if you're wondering, well, I'll do it like this. Negative B. Negative would be positive 10. Now plus minus the square root. Now here's where I do some stuff in my head. The B squared. Can we do that in our head? What's negative 10 times negative 10?
100.
It's a positive 100. I'll always do the B squared just either in my head or I'll pull up my little calculator if the number was so large. Oh, what's that? I just, let's see, so 100, negative 10 times negative 10. I'm just writing 100 rather than negative 10 squared. Then the minus I'm about to write is this minus right here. This blue minus is that blue minus. This blue 4 is that blue 4.
Because A is just 1.
Okay, so A is 1.
C is 23. So
And
there should really be that much of a deal.
4
like
times
A or 1 in this scenario because anything times 1 is just 1. So kind of like how for the B squared because it was 100, because it was 10, it should also do the same for like the 1 of like we don't really need to put it.
Yeah, I didn't need to write that 1, but I wrote it anyway. That's one of those times, okay, I did that, but I don't show the negative 10 times negative 10. I just write 100. Now, what about the bottom? The 2 times a, do I need to show steps for that, or can I do that in my head?
You can do that in your head.
If I replace the a with a 1, 2 times 1 is 2. Now, we're going to simplify that square root, the stuff under the square root. You have the calculator there, Tim. Why don't you just plug it in? 100.
Right.
So it will be
100 minus
8
8
square root.
minus 4 times 1 times 23. That's 100 minus 92. Sure enough, it gives us a positive 8.
You'll see how-
Underneath the square root.
So this square root here, all of that, I'm rewriting as just a square root of 8. But can we simplify that square root of 8?
So,
Is there a perfect square that divides into 8? That's that first day when we were looking at our perfect squares.
no.
Oh, I think there is.
I think there is. Looking at the perfect. Ooh. 4 times 2 would give you 8. Do I remember how we were simplifying things like right here? Square root of 24, we'd write it as 4 times 6. The square root of 4 is 2. That's what makes math hard. It keeps building and building. What we're doing today, we'll be doing later. Okay? Just like on the square root stuff, we did it on day 1, and then we just keep doing it all semester. Okay? So I'm going to rewrite 8 as 4 times 2. And then the purple square root of 4, I'm going to write as just a purple 2. Square root of 2. I'm about to write everything in just one color, and it'll look a little bit better now. Y'all see what I've done? Getting that 2 square root of 2. So I now have a positive 10. I'm just going to write 10. Plus minus. In place of all this circled stuff, I'm putting 2 square root of 2. All over 2. And we're not finished yet.
If we add the 2 square root of 2, it would just be the first 2, not the square root of 2, so it would be 12 square root of 2 divided by 2.
No, I don't think so.
You don't add the 10 and the 2. Those aren't like terms. If when we were adding square root symbols on the first day, you've got, in order to add square roots together, you would have had to have another square root right here. Let me see.
If there's an I on top, you're going to have to remember how we were simplifying those messy fractions in homework number 2. If there were an I here, we would split up and cancel it and get the answer in the form A plus or minus BI. But there isn't an I. So the standard method of reduction, you look at the 3 numbers outside of the square root. 2, 10, and 2. Those 3 numbers. Is there a number that divides evenly into all 3 of those?
Yes.
It is.
2.
So we're going to factor out a 2 or divide by 2 above and below.
10 divided by 2 is 5. Then we have the plus minus symbol. The 2 divided by 2 is just a 1, so it's gone, leaving a square root of 2. And hey, what do we have on the bottom? 2 divided by 2 is 1. Do I need to write over 1?
No.
So there's our answer. 5 plus or minus the square root of 2. Y'all see how I divided through there? Now, if there's an I in the answer, then I'm going to do that separating like we did in the second lesson. But going back to some of the stuff we were doing last week on that first day, if you're going to add or subtract square roots, they've got to have the same square root. Like 9 square root of 3 plus 3 square root of 3 is 12 square root of 3. 9 square root of y plus 2 square root of y is 11 square root of y. Why were we not able to add the 10 and the 2? There's not a square root on the 10. Okay. So you type in 5 plus or minus. Okay. 5.
This is no good. I need to shrink that.
Okay, make it small.
Okay. 5. And then we go to the plus minus key. Before they put in that plus minus key, you would have had to type 5 plus the square root of 2, comma, 5 minus the square root of 2. And if you put the comma under the square root, they counted it wrong without telling you why it was wrong. So that's
This
why the
plus
square
minus
root,
key is
plus
really a
minus
nice
thing
key.
was a really nice invention for
I remember I
Pearson.
was just so thrilled.
Still works if you do like 5 plus square root.
Yes, it does. Yes, it will. You'll notice they never even updated their instructions. They kept use a comma to separate answers as needed. Well, if it's a quadratic formula with a plus minus, you don't need to write it twice. But they kept those instructions. You could have typed 5 plus the square root of 2, make sure the comma is not under the square root, and then 5 minus the square root of 2.
Okay, let's do number 9.
I was going to ask if you could do it just to show us that it would still work.
Oh, well, we'll
the
type
next
this
time.
next one in like that. 2x squared minus 13x equals 1.
I'll do this one.
Oh, good.
Wait, no,
Lower it. There.
I think I moved this thing earlier. I moved it back if you'd like to. Yeah.
Is it in the standard form it needs to be in, or do we need to move something around? Move that 1, I heard someone say. That's right. We need a 0 on one side. It really doesn't. Usually the 0's on the right, but when we do number 14, you'll see the 0's on the left, and that's fine.
So we
Doesn't matter.
move that positive 1 over, and we get what here?
Minus 1. Oh, wait, you want to ask me?
I wasn't asking you, Tony. Okay. Let's identify our A, B, and C values. What does A equal? It's the number in front of the squared variable. 2, okay. And B? Oh. B equals negative 13, I agree. And C equals negative 1, okay. Some people are worried about answering. They think if they answer the wrong question, it's going to, say the wrong answer, it'll be picked up on these microphones. It's not that sensitive. You could sit out there and say 4,000 and the recording wouldn't pick it up, okay? So don't worry about saying the wrong answer. And then we're going to identify, I'm going to write down my quadratic formula, write it down for every problem until you have it committed to memory.
Okay, so let's start plugging in.
Okay, wait a minute. I like to put my plus minus. There's my square root. Negative B. We want the opposite of 2.
B.
Oh, well, yeah, you're right. Negative B, we want the opposite of negative 13. Thanks. Positive 13. And B squared, I think that's something we can do in our head. You take negative 13 times negative 13.
Let me pull up.
169.
That's a positive 169. And if you're not sure, you say,
For demonstration, take negative 13 times negative 13. Negative times negative is positive.
and it gives us a positive 169. And then a minus 4 times, okay, so minus 2, A is a 2, C is a negative 1, What about the denominator? I think we can do that in our head. 2 times a, 2 times 2 is. So we have a denominator of 4 at this point.
So now, Tim, circle that square root and draw a little arrow out to the side because we're about to simplify that square root using my little calculator here.
Okay, so all of this stuff here. We have a square root.
Okay, let's see. We have 169 minus.
It would be actually plus 8 because the negative 4 times 2, which is negative 8, times negative 1, so it will be plus 8. So it will be 177.
Did y'all hear that? The 4 times 2 times negative 1. Well, negative, minus and negative 8, so it will be plus 8. So 177.
So we now have 13.
Well, let's see if we can simplify that square root of
Plus or minus
177.
the square root of 177 all over 4. And we're simplifying this. We're going to try to simplify the square root of 177. I can tell it's divisible by 3, but 3 isn't a perfect square.
So remember how let's see, 177, certainly numbers bigger than 100, they wouldn't go evenly into 177. So let me start with 81. 177 divided by 81.
Clearly not.
No. 177 divided by 64. 177 divided by 49. 177 divided by 36. What are y'all thinking? Are we going to be able to simplify this 177? No. But you see how I'm thinking? I'm trying to show you my thought process. Why do I decide we can't simplify that square root of 177? Well, none of these perfect squares will divide evenly into it. 177 divided by 9. And 177 divided by 4, of course not. So, this is actually a good thing. I think he's finished with it.
The square root of 177 can't be reduced. That means there's no number in front of the square root. Now, if there's no number, then there can't be a common factor. That's like a coefficient of 1, 13, and 4. Dividing through by 1 would not accomplish anything. We will leave this as our final answer.
And just for historic sake, and because it was asked, I'll show you how we used to have to type these in. Before they had the plus minus key, you would have to type in a 13 plus the square root of 177 all over 4. Then hit a right arrow and put a comma.
Another fraction bar.
13 minus the square root of 177 all over 4. Now, y'all wouldn't enter it like this. Because of the plus minus key, y'all would just enter it right here and put plus minus. But back in the olden days, before the plus minus key, that's how you had to enter it. Okay?
Any questions there? Just keeps getting easier and easier, doesn't it?
Okay, let's do number 11.
Okay. Well, that looks easy, so I'll let you do it.
Okay, for sure.
It looks amazingly similar to the one I did, doesn't it?
Oh, wait.
It's not the one.
Oh, maybe we should do a different one.
It looks somewhat similar, but it's
Let's do it.
Okay.
Let's
Number
see.
11. 2x squared. Oh, I know. I'm going to let y'all look at it tight before I write it. Okay, 2x squared. Okay. Well, You're right. It's very much like the one we just did. We need to move the
Then we can
1
do it fast.
over 2x squared minus 7x minus 1 equals 0.
And now let's identify our A, B, and C values. What's B, y'all? What do y'all think B is? -7. Okay. And C? No, I think it's still it's a -1. It was moved over.
I saw the one underneath the thing, so I thought that was like.
So I didn't realize 9 and 11 were so similar.
Oh, now wait a minute. You know
No,
good and
the
well
numbers
that just
change,
because
yeah.
yours is ours is similar doesn't mean theirs is going to be similar.
Yeah. I'm writing down the quadratic formula. -b plus minus the square root of b squared minus 4ac all over 2a. And now I'll start punching in. Not punching in, plugging in. -b. -7 is that just going to be a +7?
You say that like you're not sure, Tony.
Well, you see, when I'm not answering question or asking a question, I show uncertainty because the way at times when I sound uncertain, the way most people's brains work is if you hear someone that sounds uncertain, your brain will automatically start trying to see, is that right? So when I sound uncertain, is -b -7? Is that a +7? Your brain is automatically going through, yeah, that's right, if you're listening to me. That's how most brains work. So when I sound uncertain, like right here, b squared, -7 times -7, is that a 49? Most brains, when they hear this uncertainty in my voice, starts going through trying to figure out, is he right?
Before we go on, I had a student email, okay, about this.
Just now?
No.
Oh.
I was answering emails this morning, and it may be someone from this class. I didn't look and see which class it was, but it was along the line of, it was with regards to this something squared here, the b squared. They were going -7, and they were squaring it, and look at what they were getting. They were getting a -49. Well, notice how we say -7 times -7, and that gives us +49. What they were typing in here, they sent me a little screenshot through Canvas that I was able to look and easily know, oh, they're not. If the way they wrote it, the only thing being squared is the 7. If you want that negative squared, you have to enclose it in parentheses. Parentheses, -7, right parentheses, squared.
Or just hit the square
Or hit the
key.
square button. I never use that square button. But the important thing is, negative times negative is positive.
Because of that common mistake, that's one reason for doing this b square, I'm not punching it into my calculator.
I know it's going to be
Saying
positive.
-7 times -7. Okay? Now, we still have a -4 times a times c. A is a 2. C is a -1. And what about the bottom? 2 times a, what am I going to put down here? Is it another 4? I say another one because it's like problem number 9.
Once again, just because our number 11 was so similar to our number 9, that doesn't mean yours is going to be.
Yeah. Let's simplify the square root. You want to punch it into your calculator, Tim? 49 minus 4 times 2 times -1.
49 plus
Wait,
8.
where's your
Where is
calculator?
it? Let me look. There, I moved it on. So 49 minus 4 times 2 times Oh, by the way, notice something else that causes some problems. If you're using a calculator like this, realize it has a separate minus
For subtraction.
and a negative sign. If you try to use this minus for a negative, they're going to give you a syntax error. If you want a negative number, you use this symbol down here. If it's something minus something,
Subtraction.
Subtraction.
Like right there.
that's the thing. When you that's the symbol used for subtraction. This is the negative sign, and that gives us 49 plus 8, which is 57.
I wonder if that's going to simplify. The square root of 57.
I noticed one thing: 57 is divisible by 3. 3 isn't a perfect square, but if you divide it by 3, that's 19. 19 is a prime number. So if there's two prime numbers as the factors, you can try going through Tony's list of perfect squares. I can assure you none of them are going to divide in evenly.
Wow, so this is actually my number 11 turned out to be very much like my number 9.
Well, you're going to have to do the next one, Tony. Then.
7
It's not fair that
plus
you're doing
or
one so
minus.
similar to mine.
I know, I'm just copying your work. 7 plus minus square root of 57 all over 4. Oh, well, actually,
Now we can punch it in all as one
using the
answer.
plus minus.
Okay. Y'all tell me, what are we going to do first? What am I going to click first? Fraction bar, I agree. And then we had a 7 plus minus. I remember when it first appeared there, that plus minus, and Pearson Rep had told us that
There was a surprise
April,
comment.
she had a surprise for us. We'd been complaining, we need a plus minus button. And I remember standing in front of class and leaving and going next door to Tony's room.
And
Have you seen it? And he was like, yes, it's a plus minus button. And that really is pitiful that we were so excited about that. And I still get a little giddy about it, even to this day. Oh, goodness. Any questions there? All
I
right.
think number 14 would be a really good one to do right now.
You think so? 14? Okay, hold on. There must be something special about 14. Oh, I see what it is.
If you look at the examples we've done so far, flip over to here so I can point to my work.
Oh, they were writing it down.
Oh, they were, I'm sorry. Well, to go back. The first number, A, has always been positive. If you look at them from using the quadratic formula, I prefer for A to be positive. Why do I prefer that? It gets all sorts of messy stuff if you wind up with a negative in the bottom of the fraction. I want a positive 4 in the bottom, not a negative 4, like on number 9. And the same thing here on number 11. I would prefer for this bottom number to be positive. I'm going to make a note right here by my quadratic formula. I prefer for A to be positive. Oh, my red ink is gone. Throw it away and let me get another one.
I'll just put it right there.
I just refuse to believe that they have a recycle bin in this classroom and a trash can over there. I think it's all going to the same place. At least that's what they used to do.
And we'd watch them, they'd gather it up, and it'd all just be dumped into the same big trash cans and rolled away. But hopefully now they're recycling.
Now, now let's look at number 14. And let me write it down. Negative 2x squared equals negative 3x plus 11.
we need a 0 on one side of the equation. We want the number in front of x squared to be positive. So with that in mind, we need a 0 on one side. We want a positive number in front of x squared. Here's my question. Which side am I going to get the 0 on? What would be the easiest side? The left?
If I move all of this stuff over to the left, I'm still going to have a negative 2x squared. It'll be easier if you have a positive 2. What are we trying to say poorly that we should do? Move the negative 2x squared over to the right? There's no reason why the 0 must always be on the right.
Equality is said to be reflexive. It reads A equals B is the same thing as B equals A. It's still read the same way. So here we're going to get the 0 on the left side, because then it's only one step. Put the 0 here, move that negative over, it becomes a positive. And now we can identify our A, B, and C values.
I remember once, a few years back, a student coming up to me after class, oh no, they just can't, that 0 on the left, they can't understand it. And you know what I did? I said, okay, fine, here. I marked this out and wrote equals 0, there. If you want the 0 on the right, there it is. Okay, it means the same thing. 0 equals blah, blah, blah. It's the same thing as blah, blah, blah equals 0. But, well, I can't erase it. I don't have an eraser.
Well, it doesn't matter.
Yeah.
Just identify A, B, and C.
Yeah. So let's write out A, B, and C. I'm listening.
I was going to say maybe they got confused because of the fact that they're used to the equal sign, something equals 0. So maybe they put like the opposite of it, like they did negative 2x squared plus 3x minus 11.
And you're going to wind up with a much harder problem then.
So
Okay.
you should always do like
You
the
should-
lesser one, the one that...
I'll move it so that A is positive.
If you have a fraction with a single denominator, or with a single number as the denominator, it should be a positive number,
A
okay?
fraction with a negative number in the denominator is not in standard form, and you're going to wind up getting it counted wrong.
So x squared always has to be positive.
The
Not x
coefficient
squared,
on
the
x
number
squared.
in front
Yes.
of x squared.
Mhm. Now, let me see. So I have A equals 2, B equals negative 3, C equals 11. That was the tricky part of this problem. Let me write down the quadratic formula. I bet at this point you're starting to sort of get it memorized. Okay. So let's see. Oh gosh, negative B. What am I going to write in place of negative B? It'd be negative 3.
I always say the opposite of negative 3 is
Okay.
positive 3.
And then plus minus. Now the B squared. Negative 3 times negative 3 we know is a positive 9. And you'll notice on that, the way I don't try to punch that into a calculator using the square key. Because if you don't put parentheses around it, it's going to give you a negative 9 rather than a positive 9. And we all know negative times negative is positive. So minus 4, let's see, A, C. A is a positive 2, and C is a positive 11. Are y'all caught up with me? All over 2 times A, 2 times 2, is that going to be a 4? Oh, you see, there I am showing my uncertainty. I do that out of habit. Just like Tim with his square root symbols.
Well, I sort of stopped that.
You were doing it earlier.
Was I?
Yeah.
Oh.
Okay, let's simplify the square root.
Oh, no. I'm trying to get the calculator.
Uh-huh. So, under the square root, we'll punch in a 9. Ooh, let's clear up that calculator. 9, subtract 4 times 2 times 11. Is that a negative 79?
So 9 minus 88, which gives us a negative 79 under the square root. What letter is going to appear in our final answer? I, because the thing under the square root is negative, they're going to be stuck with an I.
Okay, because of that negative, we'll have an I.
Is 79 a perfect square? No. Is there a perfect square that would divide evenly into 79?
Is there anything that divides into 79?
1 and 79.
Well, other than 1 in
Oh, okay.
itself.
79 is prime. They're actually being pretty nice to us, giving us numbers under the radical that we don't have to do a lot of reduction to.
So I'm now going to write it all in just one color. We'd have a 3 plus minus I square root of 79 all over 4.
And think back to that second homework assignment. I guess it was a week ago today. Was that a week ago today? It seems so much longer.
So we were doing the I's.
Yeah, it seems like a long time ago, doesn't it?
We had some.
Oh, it's a holiday weekend. That's what.
It didn't affect them.
Oh, okay.
Yeah.
Well, anyway, think back to what we would do. If you have a fraction with an I on top, you can't just leave. They want it in standard form, A plus, in this case, A plus or minus BI. So remember those little marks that Tony would make, splitting
And
up?
Split it up. But I want to see, do they make us split it up this
I think
time?
we should be consistent and always split it up, because there are certain problems where if they
Okay,
don't,
if you
on the
don't,
test,
you're right.
that if they don't split it
Okay.
up, then it's going to be counted wrong.
So we have 3 over 4 plus minus I square root of 79 all over 4. Do you remember the splitting up the messy fractions from a week ago? No, nothing cancels. Although we can't cancel anything with the 3 over 4 and the I square root of 79 over 4.
Now, there's the last week ago, it would just be either a plus or a minus. We hadn't introduced this concept of plus minus yet, but it was the same method for simplifying. That number there over the denominator, all that second stuff over the denominator. Any questions there before we punch in the answer? Just because it's just why I can drive from here home on the left side of the lane down Ayers. My car will run just fine, okay? But standard practice in the U.S. is we got to drive on the right side of the lane, and so why can we not split it up? If it were under ideal circumstances, I'd want the program to have it set up so that you can split up all of them. But I think that the programming says for I, split it up. For the things that don't have an I, just if there's a common factor, factor and cancel, but don't split up. And why?
It's a customary practice, but you know something? We haven't tried it, and I'm more willing to give it a try. When we have one that doesn't have an I,
we'll
try splitting it up on the next one that we do. Okay, if there's not an I,
I'd like it if every time always split up, and that's how you always reduce it. But I'm worried that the programming would not accept it. I know back when they used to have all so many of the multiple choice questions years and years ago, they would the multiple choice options would be I split up. If there's no I, factor and cancel and leave a single fraction. So let's see. and pay attention to how they want the answers as you're doing the review. For the first quiz or test, you pay attention. When you're punching in those answers, and you can have your notes there by you when you're taking the test. Oh, how did they want that? This problem is similar to number 25 on the review. Oh yeah, they wanted it like this, and so you type it in the way. Okay. So these reviews and stuff that you'll be taking before the test, they're important because it's going to show you how they want you to enter those answers. Any questions there?
Let's see. Before we do number 15, I want to review something that might not seem relevant, but it will be. Multiplying fractions. If we had something like 2/3 times 6/7, the official rule for multiplying fractions is just to multiply straight across and then cancel. Like you would get a 12, 2 times 6, over 21. Now, to reduce this fraction, what could I divide above and below by? 3. That would give me what, a 4 on top and a 7 on the bottom? But with multiplying fractions, there's something called cross-canceling that you can do also. To cross-cancel, like if you look at the 2 and the 7, there's nothing you can cancel there. But looking at the 3 and 6, you could divide both of those numbers by 3. So 3 divided by 3 would just be a 1. 6 divided by 3 would be a 2. Do y'all remember this cross-canceling for multiplying fractions? So we would have a 4 over 7. This is called cross-canceling when multiplying fractions. Let's do another one. Suppose we had 1/4 times, oh, this is going to be tricky. 12. 1/4 times 12. You might think, well, wait a minute, there's not a fraction there with the 12. Sure there is. Think of it as 12 over 1. And could I do the cross-canceling there? 3 goes into, 4 goes into 12 3 times. So we'd wind up just with a 3.
1 times 3 is 3, all over 1. Yeah, I agree. You'd be left with just a 3.
What about this? 6 over 7 times 14. This will be my last review of multiplying fractions. 6 over 7 times 14. I'd write that 14 as 14 over 1.
The 7 is 14 over each other divided by 7, so it's 6 over 1 times 2 over 1. So it's
Okay.
12.
7 goes into 14 2 times, so it's 6 over 1 times 2 over 1. What's that answer going to be again?
12 over 1.
Yeah.
Or just
12 over 1, which we can write just as 12. This idea of cross-canceling is going to be very important in problem number 15. As I always say, that's, the last problem's got to be the hardest. So let's look at number 15. Do not panic too much when you see it. They can panic a little. Okay. Let's write it down. Does it look a little different from the other problems? What's different about it? The fractions. Okay.
And notice it's actually written in standard form if we wanted to work with it like this.
So you might be thinking, oh my gosh,
1/2,
A is a half.
B is 1/10,
Oh,
and C is a -1. But I sure don't recommend that you use those fractions for your A and B values.
And I'll show y'all what we mean by that.
Remember some properties of equations that you would have seen when solving linear equations in previous algebra classes. What the important one is, you can multiply both sides of an equation by anything you want to except 0 without changing the equality. We can multiply this left side by 107, as long as we multiply the right side by 107. We could multiply the left side by 1,000,000,000, as long as we multiply the right by the 1,000,000,000. We can multiply above and below on any, we can multiply both sides by any number and still maintain an equivalent equation.
In other words, A, B, C should never be fractions. If they are fractions, what we're going to do is multiply through and get rid of those fractions. You might think, multiply through by what? Well, like doing this cross multiplying here. Oops. Oh. This idea of cross multiplying. If I come over here and multiplied straight through by 2, it would cancel this fraction right here. But we'd still have a fraction here. 2 goes into 10 5 times. What's the one number that I could multiply straight through by that would cancel both of these denominators?
More specifically, what's the smallest number?
But 2 would cancel this one, but it wouldn't completely cancel this one. I'm going to give you one that's not the smallest. If we multiplied straight through by 20, you're hitting all around it. What number would I need to multiply through by to get rid of this denominator? A 10? What if I multiplied straight through by 10? I'm now going to put a red times 10 over 1 out beside every one of these. Be careful. Every term, even the 1 and theoretically even the 0, has to be multiplied by 10. Why am I doing that? I would rather have a little bit of... Oh, okay, good. I'd rather do a little bit of this cross-canceling and not have to do A equals a half, B equals 1 over 10, C equals 1, or negative 1. If we multiply straight through by 10, help me with this cross-canceling. 2 goes into 10 5 times. What number am I going to have right there in front of the x squared? 5 times 1 over 1. Is that just going to be a 5x squared? Y'all see how I'm doing that? The goal is to cancel out those denominators so A, B, and C aren't fractions. I would rather my A be a 5 than a 1/2. Over here, when I multiply the 1 over 10 by 10 over 1, what happens? Yeah, they cancel out, and we just have an x or a 1x. I'm going to go ahead and write 1x just so you can see that that's the B value now.
What's the C value going to be?
Negative 10.
You don't just multiply the terms that have fractions. You have to multiply every term. The 3 terms on the left, over here multiplying by 0, that doesn't change anything. 0 times 10 stays a 0, but still, you're technically multiplying every term, even the term on the right, by that number 10. And do you agree this looks a lot better?
And once we're through with number 15, I'm sure you'll be thrilled to hear we're going to regenerate it and do it once more, just so that, because there's only one of them in the homework, but I want you to see 2 examples. So A is 5, B is 1, C is negative 10, I'm writing down that quadratic formula, and I'm now going to start plugging in the numbers. Are y'all caught up with me? Any questions? Why did we multiply by 10? To get those denominators to cancel.
We could have used 20, but then in the process,
Oh,
A,
no.
B, and C would have been bigger.
But
and
at
you'd
least
have a
they wouldn't
lot
have been
more-
fractions.
Yeah, but you'll have a lot more reduction at
But
the
you
end.
have a calculator to help you out. So, okay, so negative B. B is 1. So negative 1 plus minus the square root of, let's see, B squared. 1 squared is 1. Minus 4 times A times C. So 4 times 5 times a negative 10.
It'll be 200.
What's the- And the denominator is?
2 times A, 10. So simplifying under the square root symbol. Yep, 201, I think that's right. Oh, there's some of that uncertainty. I think that's right. That's my way of saying I know it's right, but this way it gets your brain, most people's brain, starts, y'all see that 201? Oh, wow. Is 201 well, it's not a perfect square.
It's divisible by 3, I bet you. If we try dividing it by 3, that's a prime number, 67. I don't think we're going to be able to reduce the square root of 201. Let's see. Oops, wrong thing. Say 201, trying to divide it by something like 100. Obviously, it's not going to go in evenly. 201 divided by 81. I'll let y'all go through and just convince yourself. If you don't believe that 201 can't be reduced, the square root of 201 can't be reduced, go through your list of perfect squares until you convince yourself it can't be simplified.
So now I'm going to write it all with just one color. And I would stop right there, but I think if you separate it, that it'll still take it.
Let's see.
Okay?
Let's
I
see.
think it will. I think separating is never the wrong thing to do, but Pearson, for eyes, they want you to separate, not leave it as one big one. Let's try to, theoretically, both of these answers are perfectly fine. I know for a fact that Pearson will take this one. Let's see if they'll take this one. Okay. But try punching in that second. Oh, leave that out.
Here it is. So what is it?
Negative 1 over 10 plus minus. Move out before you put the plus minus. Okay. Fraction. Square root of 201 over 10.
I hope they take this, because then you could just make a note to yourself.
I'm
Whether
always
it's
going to
an I or
separate.
not, you could always, they took it. So they don't take it if you leave the I's on top, but if there's no I, you can still separate and they'll count the answer correct. That's a big deal, okay? At least from my point of view, it's a big deal.
And I promise y'all we'd do another one of these so you'd see 2 of them.
So here goes.
Oh, I hope it changes.
I'm going to
Okay.
do this one.
Yeah, okay. Okay. Now, as I'm writing this problem down, y'all be thinking, what could you multiply through by so that
you can cancel out.
both of those denominators. A 7 would cancel out the first denominator completely.
I think you're looking at, when you say 7, I think you're looking at the greatest common factor. Both of those numbers are divisible by 7, but what we want here is the least common multiple. Okay, what's the smallest number that 7 divides evenly into and 21 divides evenly into? 21. So I would go through multiplying by 21, multiply by 21, multiply by 21, and multiply by 21. Oh, wait, let's switch over.
Oh, wait, 10. I messed up. Oh, there.
Yeah. Okay, so we want to cancel out both denominators. If we had just used a 7, we'd cancel out the first one. But if we had put a 7 here, what would we still be stuck with in the denominator? I think we'd be stuck with a 3. So then we'd have to multiply 3 by 3. I guess you could do it like that, but we can do it all in one common step. 7 goes into 21 3 times. 3 times 1 gives me a 3x squared. Plus 21 goes into 21 one time. 1 times 1, all right, that is a plus 1x. Negative 1 times 21, I agree with that, minus 21. And 0 times 21 is giving me a 0. We'll identify our A, B, and C values. A is? No, just 3. B is? The number in front of X, just a 1. And okay. And we have been very consistent writing our quadratic formula for each one of these. So write my little fraction bar, have my plus minus, there's my square root, minus b, the opposite of b. The opposite of positive 1 is, so we have a negative 1, b squared. 1 times 1 is a 1, minus 4 times a times c all over, what's the denominator going to be? 2 times a. 2 times 3 is 6, I agree.
Now I punch in that square root stuff in my calculator.
Here. That's going to give me a square root of
1 subtract 4 times 3 times negative, notice where the key is that I'm hitting the negative, 21 equals,
so we have a square root of 253. It's not divisible by 2, not divisible by 3. Y'all think it's certainly not a perfect square. Show them it's not a perfect square, Tony.
Okay. On the way to do that. Square root of 253. Oh gosh, so let's see. What about some of these perfect squares? Not 100, divided by 81.
No.
253. What about 64? No. 49? No.
Y'all can play around if you're uncertain, but I'll tell you right now, the square root of 253 can't be reduced.
Okay. So I guess that's actually a good thing.
So-
Write it down all as 1.
We have a negative 1 plus or minus the square root of 253 all over 6.
And I think on this one I'm going to patch it in with the plus minus.
I mean, as
with
I
the
said,
one sub big fraction.
although I think we've discovered that you can always just separate, whether there's an I up there or not. If you want to be safe, you can always separate. You would have a negative 1/6 plus or minus square root of 253 over 6. Pearson will accept either of those answers.
Any questions on this?
Some faculty members don't like my math lab because of the way the numbers are regenerated. I'm reminded of years ago, 14 years ago, we were at a conference in McAllen, and our sole purpose was just to stand there in front of, I didn't realize it was going to be a group of hostile teachers, but all we had to do was just tell them, oh, we use it and we like it, okay? The workshop had been going on all day. They provided a nice lunch and stuff, and finally, the presenter said, "Okay, I can tell all of y'all are upset. What do you dislike about my math lab?" And someone said something along the line, "You can't get the same numbers," or something like that. And the presenter didn't understand. And the other people joined in. Yeah, I want to go to class and do the same problem all the time, so I get the same answer and I know I'm right. And
that's
that doesn't happen. If Tony and I came in here tomorrow, you look at the videos. The problems are always changing. I can't even go and do the same problem from one class to the next. But even despite that, notice there's some nice.
Even though the homework is past due, you can still click on it and either practice and review or improve your score. Okay, and so if you haven't done the first assignment, it's not too late.
I was trying to make the point that even though these